Since the last video, I went ahead and added a couple of more nodes so that we can save some time. In the .NET, I have our in-between fractures and the soft solver, which is the same exact thing that we did last time where we deactivated the pieces as they fell down into this group. So, nothing too fancy there. What I'd like to do now, though, is focus on activating these pieces. And what I'll do is I'll spawn some points all along here. I'll copy some spheres, turn those spheres into volumes, and use those volumes to mask out the active attributes. So, starting with an object merge, let's go up here and find our spot that we Boolean this out from. So I'll say that this null right here is our in-between fracture out, like that. And so we just grab this guy, like so. Okay, VDB from polygons. We'll make a fog VDB. We'll scatter some points, like so. For right now, we'll turn this down a little bit. We'll make a sphere, change this to polygon. So we got that guy. Copy the points, like so. And then an attribute randomize for the P scale. So we'll go here, we'll say P scale, minimum value of, let's say, 0.1, and then we'll just keyframe this global scale. So we'll end up doing something like this. Start at 0 and then go up to, let's say, a value of 2, so that we end up doing this sort of thing. Now, eventually, all this turns into a volume. That means VDB from polygons. We'll turn this into a fog called density, and this is what it looks like in our viewports. Let's also template this guy to be sure that we're covering everything. Right now, we're not. So on the attribute randomize, let's actually turn up this global scale until everything is covered. And there we go. Now what we ought to do is use a wrangle to sample that volume over here. So we'll say set active. Second input goes over here. We'll first of all capture the volume. So we'll say that's equal to volume sample, input number 1. It's called density, and take the current position. And then we'll say if the capture vol is greater than, let's say, 0.1, then go ahead and set I at active equal to 1. And to double check everything, our color, let's set that to red. Okay, so now we go over here to our set active. Let's use the add sop, plug that in, delete geo but keep the points, and we can see there's our mask that eventually covers everything. Okay, so now that we do this, let's go to our .NET and see what that gives us. So far, nothing, because we also need to specify this override attributes. So we do that, and then we just set this to active. Let's try that now. And as you can see, that now improves the overall timing of the breakup. So that's awesome. Let's now actually focus on these collisions, though, and talk about the plates. And so I tried a couple different ways of doing this. This actually took a long time for me to experiment with the right way of doing it. What I found here is that we have the plates, right? And let's just kind of draw this in a little bit so we can visualize it. That's what we're colliding against. The problem is if we animate this, and let's say this plate is going down as it is in what we have originally, right? And let's say this plate right here is going up. What can happen is it can cause an area to get pinched. So let's say these two plates kind of go towards each other. They pinch right there, and then they send the pieces going upwards, and it causes a very weird jittery look to it. And so, that's kind of a problem because we ultimately want to have these pieces going downwards. We're trying to get the downwards motion on all of these in-between pieces. And that's good because it's going to expose all the work we just did on the sides of these plates crumbling apart, right? So again, these guys go down, it reveals the crumbling plates. And so that's a good thing. So what I found is instead of animating these plates, we should keep them static. So that's number one. The other thing here is that if we have, let's say, a piece and it happens to pop out like that, we don't want pieces resting on top of these static plates, because if a piece does that, and let's say this plate dipped down, it can provide a situation where we have some of these pieces floating in air, right? So what we should also do is take a plate, say, this guy right here, and we should extrude them upwards a little bit so that these pieces always go down into the cracks and crevices, and they never have a situation where they are allowed to just chill on top of the plates. So again, take these plates, extrude them upwards so that we always keep these pieces along the cracks. So that's another thing. And then lastly, we want to have something for those pieces that are violently shooting upwards. And there's different ways you can do this. The way that we'll try doing it is via a metaball force, which is situated underneath these pieces a little bit, or at least towards the bottom zone of the in-between fractures. Now, you could also do this with instancing particles, and you could make this a separate simulation. But in this case, as long as our collision meshes are tall enough, we're still going to have those pieces falling into the cracks and crevices. I know that's a lot of stuff, but hopefully that makes some sense. Okay, so with that in mind, let's bring in those plates. Object merge. Let's go all the way back up here to the primary stream. So we got these guys. We can also take advantage of the Boolean in this situation. So let's just take a copy of that Boolean, Control C, and we'll take this whole thing where we had the camera. So copy that. I'll set it to manual so this doesn't freak out when I paste. Paste it, disconnect all that. Here is the camera volume. Here is our plates. First things first, Boolean these two out. And after doing that, we need the opposite. So we need to, I believe, subtract A from B. There we go. Let's also shrink down the collision on this using a volume. And so here's what I'm talking about. VDB from polys. It's fine that this is a distance VDB. Voxel size down to 0.05 or maybe even less, 0.03, let's say. Reshape SDF. We're going to erode. And erode this a fair bit. So I'm going to offset this by a value of 5. And that's maybe even less than that. We'll say 4. It's quite a bit, but it's going to help our pieces from getting stuck. So, and that's just something that I've found out ahead of time. So give that a fair bit of offset. VDB converts. We'll convert this back to polygons, add some adaptivity. And then last but not least, we'll use a convex decomposition to break this up into a bunch of convex holes, with the max concavity at, let's say, 0.2. Okay, and there we go. Now we end up with something like that. Let's also do a file cache so that this doesn't really have to think about all that anymore. We'll say this is our geo folder, .os.bgeo.sc, and we'll call these our colliz plates. Save current frame, save to disk. And then last but not least, we're going to read this in, whoops, with a file, copy parameter, paste relative reference. And this will become the second input here to our DOPNet. Let's also set this to manual, make a copy of the in-between fractures, merge them together. There's our new object. We'll call this guy the plates, like that. And for the plates, we want to set this as a static object. We don't need to overwrite the attribute. And just to double check that this is all looking nice, set this back to auto update and go to the bullet data, show guide geometry. It'll take a second to think about it. And I'm glad we did that because we need to now set this to the second context geometry. And, well, we don't see anything. Why is that? Because we forgot to set a name. We're just going to use this assemble, and let's also use the output prefix as colliz islands. So we'll say that. Be sure that you do put a prefix, though, because you don't want this name getting mixed up with the names over here. So we want to specify that. And then also up here towards the top, I have a transform which scales everything up in the Y direction. As I mentioned before, we don't want any pieces landing on top of these islands and getting stuck. So when I turn this off, it should scale it up in Y by about 5, and then that pivot translate is negative 0.05 so that it scales from the center. So you do that. I turn down the collision padding as well so that that doesn't go too crazy. And I believe that's all we need to get things going on this. Let's go ahead and play this out and see what that gives us. So as we can see, it really just adds a lot more variety to how these things fall down. We do have some pieces that are hanging out up here though. And so we'll have to figure out what to do with that. And also there's another thing that I haven't told you about yet that's really good to know. Because sometimes you have these pieces, they just kind of get suspended in midair, and it actually has to do with something that's not really collision related to the plates, but has to do with bad geometry. So I'll show you how to troubleshoot geometry in the next video, and we'll take care of any pieces that might be messing this up.